2013 BC Calculus, question 5. Whenever you need to use L'Hopital's rule, I cannot emphasize enough that you must write the two limits. I'm going to, in fact, sit here and write it myself just to overemphasize it. If you do not write down the limit as x approaches 0 of the numerator function and say what it is equal to, and painstakingly, as it is, write this down, limit of the denominator is equal to. If you do not do this, you might as well leave this problem blank. Do you understand what I'm saying? Because I know I said this a lot in AB, and when I graded some of the finals, very few people actually wrote these limits down. And that tells me that I need to emphasize this a lot more. Let me say that again. If you do not write both numerator and denominator limits separately on their own, you might as well leave this problem blank because you will not get any points for it. Understand that. Now, when you're finding the limit, you're using the fact that it says f of 0 is equal to -1, and so that means that this is -1 plus 1, which is 0, and we know the sign of 0 is 0. So you use L'Hopital's rule, and you are able to say that that limit is equal to, and if you don't properly write limit as x approaches 0 and just take derivatives, then you're probably going to lose points because you are not correctly showing your work. Showing your work means write the limit in front and then derivative of numerator, derivative of denominator, and then reevaluate. We know that the cosine of 0 is 1 for f prime because they told us that y was equal to f of x. Then dy dx is going to tell me f prime at whatever point that I want to know. And the point I want to know is this point. So I plug in x equals 0, y equals -1, and I end up getting a 2. And then I'm going to bring the answer key up to show that that is worth 2 points. 1 point for using L'Hopital's rule. But to get that 1 point, understand you have to say these two things. Then you have to get to this point. From there, the answer is 1 point, but you cannot get the answer point without doing all of the L'Hopital work. So part B with Euler's method was the reason that this is a BC problem and not an AB problem. And while I'm erasing to make way for cleaning it up, the AP test shares 3 free response problems with AB and BC. You know that you are not on a shared problem when one of the parts uses a BC topic. But you will find in every test that you look at for every year in the BC exam, 3 of the problems will have no BC material at all. And 3 of them will at least have one part have BC material. All right, for part B with Euler's method, it's telling me that I'm starting at x equals 0, and I have this information, so I'm going to write that down, that my initial x is 0, my initial y is -1. Then it tells me that the steps, about the step size, 2 steps of equal size to get to 1/2. I'm going from 0 to 1/2 with 2 equal steps. So that means that this has to be 1/4, and the step size is 1/4. And then I'm ready to start playing the game. I drop down the previous y value of -1. I add the step size times the slope. When I find the slope, I have to use the previous sub-0 points. And I'm plugging them into this slope formula. However, we actually just did that. We know it's 2. And so negative 1 plus 1/2 gives us negative 1/2. Then I move on to find my y sub 2, and I drop down the previous y value, plus the step size times the slope. Very important, you must use the sub 1, what I have highlighted in blue. If you put in any of the yellow highlighted ones into the slope formula, you will be incorrect. Now, since this is the last one, you don't have to simplify. You can just kind of leave your answer in with a bunch of arithmetic yet to be done. So for the y squared, I'm squaring negative 1/2. That gives me 1/4. Times, I'm plugging into x, 1/4. So I'm just going to go 2 times 1/4 is 1/2, and then a plus 2. And I'm going to call it a day, because I'm afraid if I do any more arithmetic than that, that I'm going to do an arithmetic mistake. And so this is the approximation of f of 1/2. And I'll pull the answers up to show you the points. Where did it go? 1 point for using Euler's method, 1 point for not making mistakes while you do it. And oh my goodness, without a calculator, I am certainly not going into fraction world where the denominator is 32. You know, just box that up, call it a day, move to the next part. Now, very, very, very important. When you have the differential equation type of free response problem, which you are highly likely to run into, it often has one of its parts use some kind of phrase that is basically saying you need to integrate that differential equation. And I want to warn you about something that is extremely common. People will sometimes, with free response problems, think that they need to solve that in an earlier part. And in an earlier section, they go through the integration and solve it and everything. And then get here and realize that's where they should have done it. If you don't expressly tell them, find this work in part blank where I have a circle and a star or whatever, you will not get any credit. Because it's such a common thing for people to accidentally integrate early on this, I want to really make it clear that you have to answer that question in the part where it is asked. If you have enough time to rewrite what you put in the previous part, you may want to, but you have to be extremely clear in both sections that this one is intended to be in part C, and then in part C, I intended the thing I circled or starred or whatever to be in this part. It's got to be clear or no credit. Another thing I want to warn you about is it's easy to make arithmetic mistakes when you are testing. It is sadly the time when the person who's never made a mistake in their homeworks or anything, this is the time they make their mistakes, is when they're testing. And if you don't correctly separate on step 1, you might not be able to get any more credit. So it's important that you just stop and think, what am I doing? And the common mistake is that people will take this y squared and literally throw it over on the left as y squared. You have to think, I need to divide by y squared. If you think about the process, you're less likely to make that error. So I'm going to come over here and write that I am dividing y squared to the left to stay with the dy, and I'm multiplying the dx over to the right to stay with the 2x plus 2. That step is so crucial, and I have seen too many people mess up on this step when they're testing to not warn you about it. All right, then it's integration time. This is y to the negative 2, so I add 1 to the negative 2 and divide by that new exponent, and then integrating x squared plus 2x plus unknown constant. If you don't write that unknown constant, you might as well stop now because you're not going to get any more points. Don't forget that constant. You can solve for that constant at any moment that you so desire. I think I want to first rewrite the left side so that I don't see negative exponents, because those get very often misinterpreted, especially when you're in the fog of testing. So then I have my known point, and I'm going to find my plus c. So I am plugging in y equals negative 1. That makes this positive 1, 0, and then my c is 1. You are always expected to complete these problems by isolating that y. Right now I'm rewriting with the c. And all I have to do is multiply by negative 1 to both sides and then flat out reciprocate. Now, your final answer doesn't have to necessarily be in one form versus the other, as long as your y is by itself and whatever you have over here is algebraically equivalent to what it should be. I want to make sure you understand that when you do the separation of variables, those are typically 5 points out of 9, and that is a very big deal on the AP test. I have seen slim enough margins to say that this could be halfway from one score to another. Some of the margins between like getting a 4 and a 5 are very slight. The integrand, let me make sure I'm clear what you're saying.
So just like on the answer key, that third step was just putting in the integrand. Is it okay if we just go from having the 1 over y squared dy and then 2x plus 2dx and just going straight to the antiderivative, or do we have to show that we're switching the integral?
In other words, do you have to put the integral symbol on?
Yes.
I would say you really should. I can't. When they go to grade, they decide what they're going to necessarily expect to see and what they're going to gloss over. You don't want to leave yourself open to their debate of, should I expect to see that or do I let it go? So that's the best I can say about that. But that's a really important question. Okay, so then, oh, I didn't show the answers yet. Or did I? Anyway, 5 points. And let me make sure that you see, let's see if I can do the control. There we go, right there. See that? No constant of integration. Like I said, you might as well stop if you forget the plus c. But let me point out, you get 1 point for throwing a plus c on the end. Oh! And if you separate incorrectly, you open yourself up to possibly getting this score. Now, this is saying if you don't separate the variables, but if you separate them incorrectly, it becomes a matter of them making the decision of what's good enough. And it might be a question of, is the integration, these antiderivatives, are they significantly different by your mistake? And most likely it is going to be different. And so just that first step, I can't emphasize the caution that you need to take on that first step. Okay, I'm stopping